Hi everyone, in this video we are going to be adding and subtracting rational expressions. I'm currently looking at page 8 in my 1B part 2 packet, and I'm going to start the same way we started with multiplication and division, and that's recalling the rules behind how to do this with just normal fractions. So at the top of the paper you see a couple of different problems with addition and subtraction, and the first thing you should be thinking of when you think of adding and subtracting is a common denominator. Putting stars all around it. This is your key to adding and subtracting any fractions, rational expressions, anything. You need a common denominator if you have fractions. So notice in number 1, 3 over 5 plus 7 over 5. When you have a common denominator, all you're adding are the numerators. The denominator stays the same. So 3/5 plus 7/5 is equal to 10/5. We combine the numerators and keep the denominator the same. That's why you need a common denominator. So the legwork behind being able to add and subtract fractions is in finding the common denominator. And after that, you just simplify by combining the numerators. So let's look at number 2. 8 over 9 minus 1 over 4. So the first thing I look to are my denominators, 9 and 4. So I'm thinking about what number does both 9 and 4 go into that I can make this denominator equal to. One of the easiest ways to find a common denominator, I call it tradesies. So if I multiply this fraction by 4 over 4 and this fraction by 9 over 9, I then have 32 over 36 minus 9 over 36. So I call it tradesies because you take one denominator and give it to the other fraction and the other denominator and give it to that fraction. So I've given the 4 to this fraction and the 9 to this fraction. And now I've got 32 36 minus 9 36. That's hard to say. So notice this is a subtraction problem. In addition, I added the numerators. In subtraction, I'm going to subtract the numerators. So 32 minus 9 is equal to 23. And then I keep that denominator at 36. So the real only difference between addition and subtraction is the fact that in addition, you're adding the numerators, in subtraction, you're subtracting the numerators. So I'm going to bounce off of this point. Actually, I see number 3, something I really want to focus on. So in number 3, I'm not going to use tradesies to find the common denominator because in this one, 9 and 4, I couldn't think of a number low enough or lower than 36 that both 9 and 4 would go into. In 9 and 6, these have a common factor of 3. So there is a lower number than just multiplying them by each other. 9 times 2 is 18. And 6 times 3 is 18. So I'm going to multiply the first one by 2 over 2 and the second fraction by 3 over 3. So that gives me 4 over 18 plus 15 over 18. And that in total gives me 19 over 18. So sometimes you're given the same denominator, sometimes you do tradesies to get it, and sometimes you can find a smaller answer. All right, so looking below, I just want to point out a couple of things. So now we're dealing with polynomials, not just fractions. We're dealing with rational expressions. So here, I first look, do I have the same denominator? In this one, I do. So my answer keeps that denominator, 3x squared. Now I look at my numerators. I usually like to circle them like this so I can see the actual problem that's happening. So this is 7 minus 4. They're both just single numbers. 7 minus 4 is 3. Now, once I get to this point, I have to simplify. So 3 over 3x squared, I can divide by 3 top and bottom, and I have 1 over x squared. So the key here is recognizing if there is an addition or a subtraction here. In number 6, I have a common denominator, x squared minus 4. So my answer is going to have x squared minus 4 in it. And I can rewrite this problem as the numerator, so 3x plus 5 minus 4x plus 3 over x squared minus 4. Notice this minus sign. This only happens when you have a minus sign in the middle. Think back to when we subtracted polynomials. You have to distribute that subtraction sign to the next polynomial to change those signs. So this is going to be minus 4x minus 3. And this is where subtraction gets just a little bit tricky with rational expressions. So this is going to be, the numerator is going to be 3x plus 5 minus 4x minus 3. So when I combine like terms there, I get negative x plus 2. And then I've got x squared minus 4 on the bottom. I can actually simplify that expression further, but I'm going to save that for you to do. And if you have questions about it, you can ask me individually. So at this point, I am going to switch gears to page 9, and I'm going to show you how you can find a common denominator when you have not just a number in the bottom, not just a monomial, but a binomial or a trinomial or multi-term polynomial. So notice in number 9, I have x minus 2 on the left and x plus 2 on the right. Those are not the same number. And if I were to multiply one of them by a negative 1, it wouldn't just change the sign of that 2, it would also change the sign of the x. The only way to get those to be the same is to do tradesies like I did before. So I want to multiply this fraction by x plus 2 over x plus 2. And I want to multiply this fraction by x minus 2 over x minus 2. So in this one, I get 3x plus 6 over x minus 2x plus 2. In this one, I get 4x minus 8, because I'm distributing that 4, over x minus 2, x plus 2. So now when I add, my denominator is x minus 2x plus 2, because now I have a common denominator. And when I add, I combine like terms. So I have 7x minus 2. I'm going to do one more problem. Number 10 is just like that last one where I do tradesies, except for it has a minus sign. Number 11 is not like it. Number 11 and 12 are also similar to each other. So in this case, these are both just linear binomials. So in this case, I have a linear binomial here, and I have x squared minus 9 here. I know that I can factor x squared minus 9 to be x plus 3, x minus 3. And when I factor that, I notice that this has both x plus 3 and x minus 3 in the denominator. This one has x plus 3, but it's missing x minus 3. So in order to get the common denominator, all I have to do is multiply this second one by x minus 3. So now I've got 4x over x plus 3x minus 3. That's the first fraction. Plus This would be 7x minus 21 over x plus 3x minus 3. And now when I combine like terms, I get 11x minus 21 over x plus 3x minus 3. So in the beginning of this, you look strictly at the denominators to find out how you can get the denominators to be the same. Once you have the common denominator, then you look at the numerators and you look at how you're going to combine them. If you're adding, you're just combining like terms, and it's a little bit simpler to combine. If you're subtracting, like we did with number 6, you have to distribute that negative to the next set. So you have to do a little bit more legwork with subtraction in order to make sure that you distribute that negative. So this is just a little preview. This tends to be a little bit challenging because we just did all of that simplify, factor, and cross off with multiply and divide. And in this one, you have to factor. You don't end up crossing much off, or if anything, you don't cross off anything. And then you have to add and subtract and distribute and things like that. So this definitely is more challenging than 1B5. But the benefit is that addition and subtraction are almost identical. The only difference is that you have to make sure you distribute that negative to the second numerator if you're subtracting.